Okay, now let's solve trigonometric equations using sample number 5. The problem is solve the equation cosine 2 theta is equal to 1/2, where theta is greater than or equal to 0 but less than 2 pi. So here, to solve for this problem, let's just copy the given first. 2 theta cosine is equal to 1/2. Okay, cosine 2 theta is equal to 1/2. Now, in solving this problem, we can have two solutions or methods. So let's just discuss method number 1. Now, since the given problem on the left-hand side of the equation is expressed as the cosine of the sum of two angles, so that's double angle identity, we can use that identity for us to solve this problem. And we know that cosine theta plus theta is equal to cosine. That's cosine square minus sine. Cosine square theta minus sine square theta, or this could be simplified into 1 minus 2 sine square theta. All right, and cosine 2 theta. Okay, or you can also use the 2 cosine square theta minus 1 if you want to, but I will be using this here in this problem. I mean, in this solution. So I will have 1 minus 2 sine square theta is equal to 1/2. Okay, I substituted this equivalent expression with the cosine 2 theta. All right, and let's combine like terms and simplify and simplify. So this becomes 2 sine square theta is equal to 1/2, and sine square theta is equal to 1/4. Okay, and for us to solve for the value of the angle measured theta, we could take the square root on both sides. So that sine square theta is equal to the square root of 1/4. Don't forget the positive and negative sign since we're taking square root on both sides. So this is equal to sine theta equals positive and negative 1/2. So since there are two possible values for sine theta, then we could use the t table. So sine theta is equal to 1/2, and the other one is sine theta is equal to negative 1/2. Okay, so the problem here is what is the value of theta wherein sine theta is equal to 1/2. So we could use the unit circle again for us to solve these equations. Okay, so let me just fix this unit circle. There we go. So we have a unit circle, and the 1/2 could be found here. Since it's positive, therefore, the angle can be found at the first and second quadrants. Here we go. So these are the two triangles here. Okay. So this angle here is equal to pi over 6, or 30 degrees. And this is also 30 degrees or pi over 6. Therefore, the angle here is 5 pi over 6. Therefore, theta is equal to pi over 6 and 5 pi over 6. All right. Actually, you could express this in terms of pi over 6 plus 2 pi k, okay, where k is an element of integers. However, since our conditions for theta must be less than 2 pi, but greater than and equal to 0. All right, so we got these values for sine theta is equal to 1/2. And let's proceed to the next. So let's make use of the unit circle again. So sine theta is equal to negative 1/2. What's the value of the angle measure wherein sine theta is equal to negative 1/2? And it becomes negative when y, okay, this is y over r, when when the angle measure is at the third and fourth quadrants. Here we go. So here, this is pi over 6 as well. Therefore, the angle measure is That's pi plus pi over 6. That's 7 pi over 6. Okay, and this is also equal to pi over 6. So 2 pi minus pi over 6, that's 11 pi over 6. So another measures for the angle, theta, are 7 pi over 6 and 11 pi over 6. Here we go. So our values of theta are, okay, let me just erase this. The values of theta are, sorry, theta is equal to, or it's an element. Let me fix that. Okay, theta is an element of the set pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So these are the 4 angle measures which are the answers to the given problem based on the given condition that theta should be less than 2 pi but greater than or equal to 0. Okay? And if you want to check, you can do so. You can check each value of uh, theta to the given problem, cosine 2 theta, and it should be equal to 1/2. All right, now let's move on to method 2. For method 2, I will not be using the identity. So I will just be using a basic algebra on how to solve equations. So the problem is cosine theta is equal to 1/2. So here, since this angle measure is not as simple as the one we usually do, so I let this x equals 2 theta, okay? Or let 2 theta be equals x, right? So this becomes cosine 2 theta, sorry, cosine theta. Let me fix that. Cosine, here we go. Cosine x is equal to 1/2. Here we go. So what is the value of x? Okay, so let's analyze this. All right, 1/2. This is a positive value, so therefore the angle can be found at the first or at the fourth quadrants, right? So what angle is this? This is pi over 3. Pi over 3, if I'm not mistaken. So 60, no, yeah, 60. Okay, here we go, that's correct. And this one is pi over 3, 2 pi minus pi over 3, that's 5 pi over 3. Right? So x is equal to pi over 3 and or 5 pi over 3. Okay, but we knew that the value of x is equal to 2 theta, so therefore we could substitute the value of x, which is 2 theta, equals pi over 3, and the other one is 2 theta is equal to 5 pi over 3. All right? And here, we know that this could be expressed in terms of, oh, by the way, before we do this, since let's not limit our answer to 0 to 2 pi yet, okay? Let's make use of the general form of the equation in finding the value of theta in a given trigonometric equations, right? So we could express this in terms of x is equal to pi over 3 plus 2 pi k, right? Since there are infinite values of uh, k that we could use for us to solve for the value of x, which is pi over 3, all right? And also, let's say, let's call this x sub 1, and the other one is x sub 2, which is 5 pi, sorry, over 3 plus 2 pi k. All right, where k is an element of integers. Let's say positive, 0, and positive, or non-negative integers, right? Why not negative? Because we're talking about 0 to 2 pi, or 0 values of theta here, okay? So let's solve, or let's consider x of 1 first. So that's pi over 3 plus 2 pi k. And we know that x is equal to 2 theta. There we go. So pi over 3 plus 2 pi k. Okay, and here we go. Theta is equal to pi over 6. Sorry, this is pi plus pi k. Right? Now, here, guys, again, since we're talking about theta, therefore, theta should be less than 2 pi, but greater than or equal to 0. So what are the values of k here that will satisfy the given condition? So let's say k is equal to 0. Let's identify theta. Theta is equal to pi over 6. There we go. And how about k is equal to 1? Oops. K is equal to 1. All right, and theta is equal to pi over 6 plus pi times 1, which is equal to what? 7 pi over 6. Yeah, it's 7 pi over 6. Correct? However, if k is equal to 2, so this becomes 2 pi. Let's write it down here. K is equal to 2. So theta is equal to pi over 6 plus 2 pi, which is equal to 13 pi over 6, which is greater than 2 pi. So we don't consider this anymore since our theta should be greater than or equal to 0, but less than 2 pi. All right. So we have two values for theta uh, considering x of 1, which is pi over 3. Okay. So our theta is an element of pi over 6 and 7 pi over 6, all right, using x sub 1. Okay, so we consider this. Next, let's consider x sub 2, which is equal to, here we go. So 5 pi over 3. Okay, 5 pi over 3 plus 2 pi k, where k is an element, is a non-negative integer, or 0 and positive. Okay, here we go. And we know that x is equal to 2 theta. So 2 theta is equal to 5 pi over 3 plus 2 pi k. Okay, and let's solve for theta. So this becomes 5 pi over 6 plus pi k. Again, k is a non-negative integer. So let's try identifying the values of theta by using the values of k. So we have theta is equal to 5 pi over 6 plus pi k. Okay, let's consider k is equal to 0. Why? Because if it's 0, then we could find a value which is less than 2 pi but greater than or equal to 0. So this becomes theta 5 pi 6 plus pi 0. And this is equal to 5 pi over 6. And this value of theta is less than 2 pi but greater than or equal to 0. So it satisfies the given condition. All right. So k is equal to 1. Theta is equal to 5 pi over 6 plus pi times 1. This becomes 11 pi over 6. And again, this also satisfies the given condition that theta should be less than 2 pi, but greater than or equal to 0. So we also found two values for theta when x is equal to 5 pi over 6 plus pi k. Oh, sorry. When x is equal to 5 pi over 3. Yeah, here we go, plus 2 pi k. So this becomes 5 pi over 6 and 11 pi over 6. Therefore, our values of k are in the set pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. So these are the values of theta that we could use to uh, satisfy the given condition in a given example number 5. Okay? And if you want, you can check our answers by substituting these values, okay, to the given equation. Also, we can use the GeoGebra to show that this is also true, okay, to check our answer. So let's make use of GeoGebra to check that our answer is true or correct. Our answers are actually correct. So that's cosine 2x equals, oh, 2x equals 1/2. Oh, sorry. Let's go back to the problem again. The problem was cosine 2 theta is equal to 1/2. 2 theta is equal to 1/2. Okay, let me just 1/2. Here we go. Okay, these are x-axis. And let's annotate. And again, we are supposed to be considering our answers from 0 to 2 pi, where 2 pi is not inclusive or not included. All right. So what are those values? Those values are, okay, let me identify those. This one, this one, this one, and the last one here. Okay, what are those? Let me just, what are this? What are these values? All right, let me just check, guys. Okay, let's consider our x. So pi, let's say pi over 6. There we go. Okay, let me just erase everything and let's identify it again. Okay, here we go. So let's identify it again. And again, it should come from 0 to 2 pi. And let's identify the answers. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So there are 4 answers from 0 to 2 pi, where pi is not included. And we have these values, okay? So pi, 5 pi, 7 pi, and 11 pi over 6. So let's go back to our answers if we get the same answer when we solve it manually. Okay, so we have, here we go. So we have pi over 6, 7, pi, 11, pi over 6. So we got it correctly. So therefore, these answers are